Hello, we talked about several different kinds of factoring. So we talked about common factoring, which means you're checking every term to see if there's a common factor. So in this case, 5 goes into 5x and 5 goes into 10, so we can pull that common factor out. We looked at perfect square factoring. So if you recognize that the first term is a perfect square and the last term is a perfect square, then check that the middle term matches the 2ab pattern. We talked about simple trinomials, so if the first term is x squared, then we know that we're going to have x plus a number and x plus another number, or x minus a number. So we needed two numbers that will add to give me the b, whatever number is in front of x, and those same numbers have to multiply to give c. We talked about difference of squares, so if you notice that there's a subtract, and then a perfect square and a perfect square, then we can rewrite it as a plus b, a minus b. And finally, when we were looking at trinomials that have a number out front, we looked at the number out front and we put the factors below it in a little chart. We looked at c and we put the factors below it and we flipped them and we tried it. So let's try a few. Okay, so when we expand, like it says up here, we're going to multiply the x times the x, and then the x times the 3, and then the 2 times the x, and then the 2 times the 3. So now you can see that I've expanded by doing the red arrow, and then the blue arrow, and then the green arrow, and then the yellow arrow, and I get this over here. I notice that the 3x and the 2x are the same, so I can simplify this. So I combine the like terms of 3x and 2x to get 5x in the middle. This way is called expanding or multiplying the two binomials. When we look at factoring, what we're doing is we're going to try and get from this answer, this answer, back to these two factors. So in order to do that, we ask ourselves, what two numbers add to give me the 5 in the middle and multiply to give me the 6 at the end? Okay, so if we need two numbers, I usually start with the 6, and I ask myself what multiplies to 6. So 6 and 1, and I can't add those to get 5, and since all of these are positive, so there's a positive 5 here and a positive 6 here, there'll be no negative numbers in my factors. So 6 plus 1 gives me 7, which is not 5, so this is not correct. So then let's try 2 times 3. And of course, if I multiply 2 times 3, I get 6, and if I add 2 times 3, I get 5. So that would be the right answer. Then I ask myself, what gives me x squared here? Well, that's only going to be x times x. And then I use those other two factors, plus 2 and plus 3, to get the right answer, to get the two factors of x squared plus 5x plus 6. Always look for a common factor first. So I found a common factor of 3. I'm going to divide that out. 3x squared divided by 3 will be x squared. Minus 6x divided by 3 is 2x, and minus 30 divided by 3 is minus 10. And now I have a similar question to before, and I need to ask myself, what two numbers add to give me negative 2 and multiply to give me negative 10, if they exist? Okay, so I know that the factors of 10 are 10 and 1, which is never going to give me negative 2. 1 plus 10, 1 minus 10, so that would be not correct. And then 2 and 5. And I know that 5 minus 2 is 3, not 2. I need negative 2. And so I'm actually, and 2 minus 5 is negative 3, so I'm actually not able to factor this any further, and this is correct. Because I have a number up front here, I'm going to do the crisscross method, or what you call the crisscross method. If you recall, we put the a, which is 3, on the left side of the chart, and then the c is negative 2. So what I need to do is put the factors of 2 here. And if you recall, we actually flipped them around too, so that we're trying every possible combination. And now we're going to try the combinations and see if we can get negative 1 is what we want. So 3 and 2. So if this was negative 3 and positive 2, that would give me the negative 1. And just to double check that, because it looks like that's the right answer, so we're going to try the second one. So 6 and 1, that's not going to give me negative 1. So in fact, the right answer would be this column with this column. Now, if you remember, what we did was we circled them this way, and that would be the first factor, and then this would be the second factor. Again, in order for the -1 in the middle, I need this to be negative. I need the 3 to be negative. So 3 times -1 and then 2 times 1. Now I can write out the factors. Looking over here, I have a 3 and a 2 and a 1 and a -1. And of course, we don't want to forget our x's. Those are the two factors for this question. You can check your work by doing the multiplication. So 3x times x is x squared. 3x times -1 will be -3x. 2 times positive x is 2x. So our -3x this way and our 2x this way make the -1 here. And of course the +2 times the -1 gives me -2. So I'm looking at this one and I can see that this 25x squared is a perfect square and the 16 is a perfect square. So in fact this is 5x all squared and this is 4 squared. So I'm going to check to see if the perfect square formula works. So I've copied out the perfect square formula. It's a squared plus 2ab plus b squared, and so then the answer would be a plus b squared. So we need to figure out what a is. We need to figure out what b is for our question. Our a would be 5x all squared, and our b would be 4 squared. So what I want to do is I want to double check that this 2ab actually works. So this is my a, so 5x times 4 is 20, and then times the 2 gives me the 40. So that in fact does work. So now that I've written it similar to over here, I can write out the answer. So my factors will be a plus b all squared, my a being 5x, and my b being 4. If you, on the other hand, do not notice that, that it's a perfect square, you could do the a and c thing. So it would be 25 and 1, or 5 times 5. And then the c would be 16 and 1, 1 and 16, 2 and 8, 8 and 2, 4 and 4. But you can see how this would be a lot of work on this side to try and check all those possibilities. So if we could recognize that it's the first term squared, the last term squared, and then we can double check that the middle follows the pattern and then write out the answer. Okay, so similar to the last one, I'm first going to check to see if this is a perfect square, and it is not. And this one is not a perfect square either. Now I'm going to check to see if there's a common factor. So anything going to 8, 26, and 15, that would be no. All right, so then we're going to set it up with the a and c. My a could be 8 times 1, or it could be 2 times 4. And I don't have to flip those because I'm only going to flip the c's. My c could be 15 times 1, or 1 times 15. 2 doesn't go in, but 3 does. 3 times 5, or 5 times 3, and those are all the factors of 15. Now I'm going to do the crisscross to check whether anything matches. So I need to get 26 in the middle. So that's what I'm going to do. So 8 this way. I'm using this column and this column. So 8 and 15. That's only going to be 23 if I add those together, so that's not going to work. 8 times 15 and 1. 8 times 15 is a big number, so I'm not going to worry about that one either. 8 times 5, 40 with a 3, also too big. 8 times 3 is 24 and 5. 24 and 5 is never going to give me 26. Oh, it looks like I'm not going to have any of these. 8, 24, and 5. Okay, so then we're going to check off the second one. So we're done this one, and we're going to try the 2 columns. So 2 times 1 and 4 times 15. So 2 times 1 is 2, 15 times 4 is 60, way too big. 2 times 15 is 30, and 1 times 4 is 4. So 30 minus 4 would work to give me the 26. But it would mean one of them would have to be minus, and then this would be minus as well. So that's not going to work. Let's try the next one. 2 times 5 is 10, and 4 times 3 is 12. So 10 and 12 is 22, not 26. 2 times 3 is 6, and 5 times 4 is 20. So it looks like that's the one we want to be dealing with. This column and this column. Let's just double check. 2 times 3 is 6, and 4 times 5 is 20. So 20 plus 6 is 26. So I'm going to underline what I need, this 2 with the 5 and the 4 with the 3. And then I can write out my 2 factors. So my first number is 2 with the 5, and the second factor is 4 with the 3. Everything's positive, so I'm just going to put my x's in here now and the plus. And that would be the answer to this question. Okay, so I have a formula here, -1/4 times t squared minus 4t. The question is asking me to find the maximum height and how long the ball is in the air. So I'm going to use this because if you think about any formula like this, you're going to have like a parabola going up and coming down. It's going to start somewhere and it's going to finish somewhere. So if you think about the particular ball, it starts in the ground, it goes up in the air to its maximum height, and then comes down over time. So we need to figure out, it says what the maximum height is, so we need this point at the very top, and then it says that's the maximum height. It says also to find how long the ball is in the air. Well, the ball is in the air until it returns to the ground again, so that would be here. So we need to figure out the time when the ball is at its maximum, the red point, and the time when a ball hits the ground again. So it starts on the ground over here, and then it ends in the ground at the green X. If I know this green X, that happens when our factor is 0. So, because the height is 0, so we need to figure out when this is 0. I'm going to do that right now. So at this point, I need to figure out when this equals 0. Well, -1/4 is never going to be 0. So basically, I have to figure out when t squared minus 4t equals 0. That means I'm going to factor t squared minus 4t. Okay, so you'll notice that t squared minus 4t can be factored into this. There's a common factor of t in each of those terms. I pulled it out. T squared divided by t is just t, and 4t divided by t is minus 4. So what I'm going to realize now is that either t can be 0 or t minus 4 equals 0. In which case, both of those are when the ball's on the ground. T equals 0 is when the ball's on the ground right here, and t minus 4 equals 0 is when the ball's on the ground over here. I'm going to solve this equation, so t equals 4. And in this case, we're talking, I assume, about seconds. So it is after 4 seconds the ball is in the air. How long the ball's in the air, so it's 4 seconds. So this number right here is 4. So now to find the maximum height. With the parabola, our vertex, or the maximum height, is going to occur halfway between where it started and where it ended. So it's going to be halfway between 0 and 4. So we can draw a line going down from halfway between 0 and 4. When we know that that's at x equals 2, or t equals 2. So maximum height occurs when t equals 2. If that's true, then I can just use this original formula to figure out what h will be. So I'm going to put in t equals 2. So -1/4, 2 squared, minus 4 times 2, and then I'll evaluate that. Okay, so I evaluated that, and I ended up getting that the height was 1, or I assume 1 meter. So at the time of 2 seconds, the height is 1 meter. So that would be the same as having a point right here. The maximum is at 2 seconds and 1 meter high for that ball.